Hello, everyone, and welcome back to the Cloud Show. I have another very exciting topic today. We have been talking so much about Azure and cloud and leadership and all kinds of questions. But when we talk about the cloud, it's been about how to move to the cloud and what to do with the resources in the cloud and so forth. There's one more thing we haven't talked about, which I am going to cover today with the star of the show. We're going to talk about how to transition the application to the cloud. If it has old software components in it and you need to this was developed decades ago, what do you do? How do you move old code, old application pieces to be able to run them in the cloud? And the star of the show tonight is Olena Borzenko. Hello, Olena.
Hey, Magnus. So nice to be here. So nice to see you again.
It's brilliant to see you again. We just saw each other in Wiesbaden for the ECS conference. But it was still a few weeks ago now, so it's nice to see you.
Yeah, but with the tempo of life, it feels like just a few days. Sometimes where am I? What year it is? What's going on? That's always.
Which country am I in? Oh.
Yeah, actually, that's true. Luckily, have.
All right. Well, that's brilliant. So, for the audience, tell us a little bit about yourself. Who are you and what do you do?
Yeah, well, so you know my name already. That's, I guess, a pretty good start. I'm a software developer and I'm a consultant at Xibia. So I work a lot with cloud technologies, mainly with Azure. I'm also Microsoft MVP in Azure category. So I do stuff in Azure. But I started my career as a .NET developer in Ukraine. That's been a long time back then.
Mm-hmm.
But since then, it was quite a journey. I started also, since the last couple of years, I started to speak at the conferences, share my experience, also engage with the community. And whoever wants also to start speaking at the conferences, I always try to help, because I was a couple of years the same person, not knowing what I am, what I'm supposed to do. And I have all the great friends that helped me to step on the stage, basically.
Yeah.
But it wasn't always like this. I had no idea that I'm going to end up in IT, that I'm going to be a developer. I was thinking that I will be doing sport, I will be an artist. That I have a scientific background, so I have a scientific degree in applied physics, right? So there was a point in time when I didn't know what I'm going to do in Ukraine. So because the reasons, I'm not going to go deep into this. But my sister, big thanks to her, she's also a software developer, but she also finished applied physics. She came to me and said, well, you should try that. You should try going in IT because it's techy enough. It's going to be interesting and challenging for you. You're going to learn a lot of things. And also not only about tech, but also about different industries. Because she knew that I'm super easily getting distracted. Oh, I want to do that. I want to do this. And you're going to fulfill all your wishes there if you're going to work there. And, back then, IT was not exactly a thing in Ukraine yet, but that was the beginning of IT bubble. So the work, it was quite cheap to hire people in Ukraine. And slowly, the amount of companies coming to us, hiring people, started to increase. So companies started to do something called engineering camps. You go there for a couple of months. You try to understand what it means to be a developer. If you survive this time and you're good enough, they hire you, and they hire you for a few more months so you can understand what's going on in the company, and then you got your first commercial project.
Right.
I think that was such an interesting journey for me, because I was lucky enough, since I started to work in the company, I was lucky enough to get all the best projects that we had in the company. So my first commercial thing was biggest agri-tech enterprise in Ukraine. And it was enormous. It's 45 people doing the same thing and trying to fit the 5 or 6 years of work into 2 years or 3, because of course the deadlines and stuff. But starting to work in that kind of project as a junior or trainee developer after 2 years, when we left the project, we were ready for any kinds of challenges, because we've seen how enterprises getting developed, right? Yep. That's an experience. Since then, I was, I did many different things. I do remember the time when we would build the application, actually compile it. We would copy-paste files on a USB drive, and we'd go somewhere else and paste it to the VM, that kind of things.
Yeah.
Or some
I delivered to a customer once with a floppy disk. It's what the hell? I've been working, and then I compile the little thing on a floppy disk, and here it is.
That's so funny because I'm from a different generation, and it seems like I wasn't supposed to see that kind of stuff, but because the technological gap is a bit, Ukraine and the rest of the world and some other countries, we still manage to see all this beauty of all tech and all industries and so on. But it was not only that. We've seen many different things, the newer technologies, the older technologies. I think the most valuable experience that I had, and actually it kept coming to me over and over again since then, is when you work with industries that are much more stable than the rest. In my case, it's aerospace, for example. They don't change that frequent. They don't change that often. They come to you with the request that they want to also go with the same pace of technological progress and modernization as the rest of the world, right?
Of course.
But they have no. The things that they already have, the applications, they were developed through decades, and they're still functioning, no matter in what.
Running, I mean, they have those kinds of organizations have applications that are ancient, right? But they're still running, and so don't touch it.
Absolutely. Yes. And doesn't matter in which part of aerospace, for example, you are. Is it the airlines, it's the airports, or you maybe like development of the whole aircraft. They all have their own ancient dinosaurs sitting in the company. The funny thing about it, that they very often, that those people who developed this application, they already retired or left. Depends.
Of course.
So very
and
often
versions of things, right? How do you even approach something like that? You have an old system, right? So let's break it down for the audience here. You have an old system. You have old components built eons ago by people who were not even there. They took all the knowledge with them, and now the company is like, okay, so we also want to use the cloud. We want to port this thing and make it run on the cloud instead. It's like, okay, you can run it on a VM maybe.
Yeah.
Maybe if you figure out the dependencies and crap and put that in a VM and stick the VM in a cloud. But that's hardly sexy, is it?
Yeah, no, not at all. It's not just about, I'm laughing a bit because it's like really the story of my life. It's not just about like, lift and shift or something or migrating to cloud. They very often come in with requests. We want to have all this new stuff. I work a lot with Azure technologies, right? Azure Cosmos DB is one of my main things. And I often have a request from customers. They come to me and say, we want to use Azure Cosmos DB for this and this and this, and this makes sense. And we want to use all the services and all these cool things, but we don't want to rewrite the decades of stuff that we already have. We want to reuse it. We want to take some of those pieces of functionality and logic. And believe me, it does make sense, because I remember that we had a case. The application was running some calculations for creating the aircraft. 2 weeks, 3 weeks, it could have been running on a machine. If you close your laptop, it's gone. So they were literally holding the laptops, for like days and weeks up and running, making sure that no update will come. And they didn't know. Don't touch it. And they came to us with like, we want to improve it. We're like, well, maybe you want to use like some cloud computation power, and maybe you want to make it remote. Maybe you want to split those calculations and do it. The decades the application exists, they didn't get to that point that this is actually possible, because the knowledge is not there. The people that are working in this company are still using the same approaches. They are quite comfortable with what they have, and they don't want to move forward. So sometimes it does take those young pioneers or just pioneers to come and say, we're going to rebuild everything. And they will still try to protect some stuff, but...
Yeah. But I mean, given that, let's just pause for 1 second, because when you're telling this story, like I think this speaks to a lot of people who are actually listening to this show right now, that this is a common and just really unnerving scenario. It's like, we want to be on the technical forefront all of a sudden, which hasn't been a thing, but now we want to because everyone else is in the cloud, and also AI. We have to use AI, right? So that's important. Yeah, sure, it's important, but now all of a sudden it's urgent, and that to move old legacy application components or legacy applications to the cloud, and they were never built for the cloud. Why? What are the problems with applications that are moving to the cloud? Why are they not a good fit for running in the cloud?
Yeah. Well, so first of all, when they ask you to want to do things in the cloud, it's because some of the competitors is trying to do the same thing, and they're like, "Oh, we want to be first." The moment when you start doing this, you're bumping immediately into some challenges. Those old applications, they will have some connectors. You will be lucky enough if this is just some REST API, but this is usually some SOAP API endpoint, some
Oh my
old
God.
crap that nowadays, and you have people that know how to operate with new technologies, but you also need to find people that will be comfortable working with the really old frameworks, with the C++, connecting to some SOAP stuff, editing some XML files, and praying that this is going to work. So this is the first challenge. Second is the industry. When they develop such enormous application, they sell it to customers, and customers, they often come back and they say, well, I like this, but I want to have a custom configuration. You end up having an amount, numerous amount of different versions of applications that fits for different clients, right? Especially if you're talking about airports or some custom build of the aircrafts, it's going to be different for everyone. So this is the second challenge you got. What do you do in this case, right? You want to use most stable version, or you want to use the one that is mostly used in customers, or do you want to use the one that is actually supported by the team internally in the company? So all those things you have to decide for yourself. What is the core functionality you want to reuse in your applications, right?
Right.
And then you definitely don't want to just take okay, let's assume that there is REST API and you can connect to it. What do you want to do with this old application? Do you want to just run some functions, get the result, get the output, because it's usually calculations and business rules? You don't want to have it in the middle of your architecture, right? You want to probably put it somewhere down, have it under the hood running, and just send the request, get the result, and process the information, right?
Because I was thinking about one thing there when you talk about this, Olena, that another challenge obviously has to be that component doesn't necessarily run on a modern environment. The version of the frameworks and whatever has to be very specific things.
Yeah.
So if that thing is even going to run at all, it has to be running in its own kind of isolated environment with a very specific set of framework versions and things, right?
It's very often was that we would extract some of the components, some functionality, and we will put kind of some container on top of it or some kind of a wrapper, and we would run this part. So we will reuse a lot of functionality, literally extracting some of the DLLs and some of the build, packages. Another thing that's could be, you can still run it on an old good VM, right? You can do this on your environment. You can do have it on premise or have it in cloud and Azure. That's also fine. If you're lucky enough, you can containerize your application. That's actually something that we're doing now. We making the application is going to be running in the container, and we building the rest of the system with microservice architecture or microservice approach in the container. And then you can put it all whatever you want. In our case, it's, for example, Kubernetes cluster. Because another thing is, very often those industries, they say they've seen so many changes in the technologies, IT world, and so on, that they say, we want to be cloud agnostic. We don't want to be dependent on a certain cloud. We don't want to be dependent on certain technologies, but we still want to leverage some of the amazing features. It's literally the words, we want to use Cosmos DB, but we don't want to be dependent on Azure. I'm like, okay, so in this moment, you want to ask them what exactly they want from the service itself, and then you start. Okay, there is some certain features that they want to use, and then you realize, okay, if we move from another cloud, or if we ever need to run the application somewhere else, what do we do? So you select the connectors, for example, like MongoDB connector that you can actually move to MongoDB. You're not using all the built-in features of Cosmos, but you try to implement a lot by yourself because you try to be cloud agnostic. And in the end, I think they will never move to another cloud. But it still might be a case if they want to run in a different
Okay, but so essentially what you're saying is that if you can take apart an old application enough to isolate a certain functionality that you want to migrate, you put that in, you wrap it up in a container if it works like that. and then you make some kind of a more modern language. You use some kind of language to just craft a SOAP request or whatnot, and you get some junk back, and then you like pick the response apart and take out the valuable information, and then you respond from the container, and the rest of the application could be something more modern, running on, doing more modern things, talking to Cosmos DB and various things, right?
Yeah, you definitely want to have something in between of your modern application and this old whatever functionality that you're running. You want to have some kind of like adapter or something, because maybe you will change the application, maybe the endpoints will change, maybe you will need to do whatever. So you want to isolate this level as much as possible, and then expose just the API that does make sense for your modern application. Because quite often, from customers, they come with this request, and they often say, well, we want to have this functionality under the hood, but eventually we want to move away from this. Right? Because also the time is not standing on one place. They will eventually come up with some different business requirements, and maybe they will develop new components. So they want to easily switch to a different functionality block, right? So different tier. So those things, they there is a lot of challenges coming, especially with the not knowing how this application actually works, and then you need to run it somewhere in cloud, or you need to make it containerize it, and then something, for example, something fails, right? If you didn't build the application and you didn't put the logging and all the observability and metrics and traces in there, how do you find out? What do you do with the running system if one of the parts, this old part, crashes? Right. So you have to have some kind of a backup mechanism. You either spin up to different instance, or I don't know, or you stop your application and say to users, go home. Sorry, it's not working anymore. Well, it's of course joking, but these challenges, it's hard to solve them, because also,
So I guess that there's a lot of like design patterns, classical design patterns that we can apply here. You were saying proxy. Proxy is a good design pattern. So what else do we have? Like sidecars and things.
I really often, I like to, if you have a monolith, for example, and you want to redesign it or rewrite it, you use an approach called choking monolith, which is basically you develop, you take the part of functionality and you build adapters on top of it that keeping the database of the old application and a new database in sync. So it's actually like a proxy, but it's also, if you build a couple of those adapters and you substitute your logic with time, then the time will come, and then you can just drop this functionality, or you can switch to something else. And of course, when you have the systems and you have microservices and whatever, you probably want to have certain messaging patterns, right? You probably don't want to have everything through the asynchronous requests, especially if there is if there is a business process or something like that.
Right. I mean, these, like you're saying, it's usually something like calculations and things. They could take some time, and in any normal microservice or whatever architecture that you might have, you have your like main application, and it's calling this legacy component through. It's hosted in a container elsewhere. You have to send a message to that container, which then will make the request, and that has to be asynchronous because we don't know exactly when this is going to come back. And there needs to be something if it doesn't come back. What if it fails? Right?
What if it fails? It's actually true. Sometimes you send the request and it's gone. You don't wait for a response, but then you trigger some calculations or you trigger some business processes. Like, okay, the aircraft should land there and they should park there and this should be taxiway and yada yada. All those things, there are separate steps in the business process. So eventually, some of those applications that actually really like a pattern, they will have somewhere something like RabbitMQ or some other messaging thing. So you will have to connect to the messaging gear, like the mechanism, and be able to read those messages from there, interpret them, because they usually have a certain standard, and the standard, especially in the airspace industry, is like you don't wanna know those standards. They're just like ridiculously hard to read and
I
understand.
mean,
So
this sounds a lot like some kind of like a Franken code scenario. It's like you just have to make it work. Like just putting old pieces together, stitching them up. It's like,
yeah.
okay, it's
And you
walking.
try
Look,
to
it moves.
isolate it from the rest of the world so no one sees this original message. You first parse it, like so no one actually can see it. You
Yep.
wrap it, make it nice, and then you
Mhm.
send it to
Turn
your.
it into JSON or something more modern or whatever
And
it is.
how many already requests it takes? For example, if you just want to get some information from the old application, write a text there, you make a request, you get a response, you parse the response, you post you send it further in pipeline, whatever, then you save it to a different database. It's already such a big amount of steps just for a very simple action. So whatever you building on top of those applications, if you're lucky enough to put them in a container and run them in the cloud somewhere, you want to make sure that whatever connectors you have, they have a proper observability, proper logging, proper tracing, and they can actually store and save as much information from the original messages or like responses as possible. And a very, very common mistake, actually, what I wanted to mention, that people are getting carried away because it's such a big amount of functionality and stuff, and they starting to develop things around this old application instead of keeping it in the background running, because it's just so hard to work with it. Sometimes they're like, oh, well, yeah, let's just build another service. It's going to do this and just going to return the things. And they forget what's the point. The point is to build a new system, reuse some of the components, literally the gears of the mechanism, and then but have the rest of the application, the rest of the system actually nice, with a nice approach, because that was the whole point, right?
Right,
So
exactly.
if you extract all the data, then you put it in some other, you store this data even from the old application, you can use this data right afterwards for AI stuff, for analytics, for whatever you want. But you need to make sure that this new system is capable of storing data and not actually tightly coupled on your old application.
Right.
Yeah.
I mean, there's so much here. We can keep digging forever, and it's like archaeology, trying to dig out the past and figuring it out and brushing it off and painting over the ugly parts. All right. Well, we could talk, I guess, for hours about this, but we're out of time.
Oh yeah.
But I really want to thank you so much for being on the show today. I think that there is hope. You have to have some skill and patience and be very meticulous when you're doing this kind of thing. But essentially, there's hope for running old legacy components also in a reasonable way in the cloud. That's, I guess, maybe as a takeaway.
Yeah. Thanks a lot for having me in the show. It was such a pleasure.
Hey, it's my pleasure, really. This was a brilliant episode. I really loved having you on, and I hope you come back some other time. And thank you for being on the Cloud Show, and thank you, audience, and we'll talk again soon.
Thank you.